Hello, this is Eric Ahrens with the University of California speaking about Excel for Business Statistics. This is one of my initial classroom activities in which I introduce the t-test and check that students remember how to use Excel and an algebraic calculator. Let's begin with the definition of a t-test. T-test is a statistical hypothesis test in which the test statistic follows a student's t-distribution. It is commonly applied when the test statistic would follow a normal distribution. The z-test is easier to calculate with the same result for large sample sizes, but it is not accurate for smaller samples. For sample size of n less than 30, the t-test is needed. The history of the t-test is pretty interesting. The t-statistic was developed by William Seeley Gossett while he was a chemist at the Guinness Brewery in Dublin. He devised it as a way to monitor the quality of stout based on small sample sizes. He discussed his ideas with Carl Pearson at University College London and published them in Pearson's journal Biometrica in 1908. Gossett used the pen name student due to rules at Guinness, and today the method is known as student's t-test. Okay, let's try out some calculations on the t-test with this version of it that involves two data samples. So as we can see, the formula is that t equals x1 bar minus x2 bar divided by the square root of s squared over n1 plus s squared over n2. I've made up some data for each of the samples. For sample 1, the sample size, or n, equals 8. The mean, or x bar, equals 28. The standard deviation, or s, equals 12. For sample 2, the sample size, or n, is 10. The mean, or x bar, is 25. And the standard deviation, or s, is 12. To calculate this t-test with an algebraic calculator, or with Excel for that matter, we have to be careful with parentheses. Okay, so I've brought up the little calculator that comes installed on my Mac, and I'm going up to the View and changing it to Scientific. If you're using a Windows machine, you'll find a similar calculator and the ability to change it in this same way. All right, so let's get started with our calculation. We want parentheses around our numerator. I'll first clear it, and then I'll type my left parenthesis, and I need x1, which is 28, minus 25, close parenthesis. I'm going to divide this by this square root here, so I'm going to have to put that in parentheses, and I've got my s squared, which is 12 squared, divided by n1, which is 8, plus, again, 12 squared, divided by n2, which is 10, and now I've got to close that parenthesis, take the square root, and divide that into the numerator, and I get 0.527. All right, so I'm just going to type that in here so we remember it. Okay, so that was our result with the calculator. Now let's go over to a different cell here and do the same work with Excel. Now, as you may remember, to tell Excel that you want it to do a calculation, you start with the equal sign in that cell. So I put equals parenthesis, and I've got my x1, which is 28 minus 25. And I've got to divide that by the square root. The function in Excel for square root is sqrt. And so my s squared is going to be 12 hat 2 divided by 8 plus 12 hat 2 divided by 10. And So as you can see, the exponent function in Excel is this caret or hat sign here. So now I enter, and we see it calculated out the same number that we got with the calculator. A nice thing about Excel is that when I click the cell that has the results in it, now my original formula shows up on top. So if I had made a mistake in my work, I could look up here, figure out what it was, and just correct it right here. So for example, if I change this minus sign to a plus sign, it'll just recalculate using that new formula. So it allows me to fix my work, whereas on a calculator it's not so easy to do that. I'll also mention that various algebraic calculators work differently, so you don't want to borrow someone else's calculator on the way into a test. Okay, I hope you'll practice these calculations, and thanks for listening.